Now, it is important that you get to know what the different sets of numbers are called, because in the book it'll just say it's got to be a natural number and do this. So if you don't know what a natural number is, that will affect, whether you can work the problem. So starting out with the natural numbers, we also call those the counting numbers, because you start with 1 and then go to 2 and then go to 3, 4, 5, 6, 7, and so on. Okay, so keep in mind it starts with 1 because that's the first number you would start with to count. And we're using a capital N. Every textbook is different. Natural numbers usually sticks with an N to denote that set of numbers. So any natural number can be expressed as a product of 2 or more natural numbers called factors. A lot of this vocabulary that I'm going to throw at you, you've heard it before. Maybe you just didn't formalize the meaning of it. And so I'm just going back over it just to make sure we're all on the same page. All right, so I mentioned earlier that we're going to talk about divisibility. We say that A, notice I put it in quotes because it's standing for a number. We say that A is divisible by B if the operation of dividing leaves a remainder of 0. So one way that we can show this definition mathematically or with symbols is like this. So, and I see a typo. Equivalently, B is a divisor of A. So we can write it like this. B divides A. That's how you would say those symbols. B divides A. So the first number is the one that has to go into the second number evenly when you write it this way. So for example, 5 divides 25 evenly. So that would be a true statement right there. 5, that bar, 25. If the first number does not divide into the second number, then you would just put a slash through that symbol. So this is 3 does not divide 16. Okay, so keep in mind that you're not going to be using a calculator when you're working these problems, and you may be asked if a certain number is divisible by another. Now, and when I say this, let me stress as well, don't do your homework with a calculator. Because if you do your homework with a calculator right now, you will not be prepared when it comes for the test. So do your homework without a calculator for these 6 sections in Chapter 5. Now, a lot of numbers have little tricks when it comes to being divisible. I think that most of you know if a number is divisible by 2. Because if the number is even, then you know that it's divisible by 2. So that's the trick for that one. Now, most of you know when a number is divisible by 5. Because if the number ends in 0 or 5, then it's divisible by 5. And I hope that most of you know when a number is divisible by 10. Because if it ends in a 0, then you know it's divisible by 10. So some of these tricks you were taught, as you were growing up and you've learned them. The other ones maybe aren't as well known. So for example, the number 3. The sum of the digits is divisible by 3. So if you add up all of the digits of a particular number, and that is a number that you know is divisible by 3, well then that big number is divisible by 3 also. So for example, 52,341, that's a huge number to have to wonder if it's divisible by 3. But if you add 5 plus 2 plus 3 plus 4 plus 1, so those are the digits in that number. Notice you add it and it equals 15. Well, 15 is divisible by 3, so therefore that big, huge number is also divisible by 3. Okay, maybe a trick you're saying, that would have been helpful to know all these years, okay? Yeah. So, yeah. All right, for the number 4, if the last 2 digits of a number are divisible by 4, then the entire number is divisible by 4. So looking at 3,947,136, just looking at the last 2 digits, 36, is 36 divisible by 4? Yes, so therefore that big, huge number is also divisible by 4. Okay. Jumping down to number 6. Number 6 doesn't necessarily have a trick of its own, but notice that you can get a 6 by multiplying a 2 and a 3. So if the number is even, it's divisible by 2. And if the trick for number 3 works on that number, so if both 2 and 3 work, then 6 is also going to divide into that number as well. So that's how you know for 6. If 2 and 3 work, 6 works. Not every number has that, okay? Not just because other numbers are factors of it, doesn't mean, but number 6, that is the trick. So 954, when you add up the digits, notice you get 18. 18 is divisible by 3, and it ends in 4, so it's divisible by 2, so therefore it's divisible by 6. Okay, number 8. This is similar to number 4, and really if you think about it, it's a pattern with number 2. If the last digit's even, then it's divisible by 2, right? If the last digit's divisible by 2, then it's divisible by 2. If the last 2 digits are divisible by 4, then it's divisible by 4. And if the last 3 digits are divisible by 8, then it's divisible by 8. Okay, that's how that pattern works. Notice it's 8 is equal to 2 to the 3rd power, so that's why you need 3 digits. 4 is equal to 2 squared, 2 to the 2nd power, so that's why you need 2 digits at the end. So this big, huge number right here, 593,777,832. This one's a little harder because it's 3 digits. So 832, being that you're not using a calculator, this is where long division comes in. So you might have to do some long division on some of these front, but you don't have to do long division into the entire thing. That could take forever. You only have to do long division into the last 3 digits. So it doesn't matter to me how you do your long division. I know that if you grew up in another country, then you're going to do long division most likely very different from how I'm going to do it right now. So that's totally up to you. If it's a show your work problem, just show me your work however it is that you do it. But just a little refresher, those of you that have been very attached to your calculator for too long. Okay, 8 into 832. So we're going to do 8 into 8 goes in once. 1 times 8 is 8. Subtract, and you get nothing. Bring down the next digit. Does 8 go into 3? No, so we need a 0. And then that gives us 0. And then when you subtract, you get 3. Bring down the last digit. So 8 goes into 32 4 times. And then 4 times 8 is 32, and you have a remainder of 0. So that's what tells you that it is divisible by that remainder of 0. So therefore, this checks out, and that means this really big number is also divisible by 8. The next trick is 9. So you know how 3, you have to add up the digits to see if it's divisible by 3? Well, 9 is very similar, but that number has to be divisible by 9. So add up all the digits, looking at 5,346. So if you add up those numbers, it equals 18. Okay, it didn't show it to you here, so adding that up, that equals 18. And so therefore, since 18 is divisible by 9, then that large number is also divisible by 9. They skipped 11 on here, but 11 does have a trick, so I'll come back to that in a moment. Looking at number 12. 12 and 6 are very similar. If the factors of 12, if 3 and 4 work, well then 12 also works. Notice that it's not 2 and 6. It's got to be 3 and 4. If 3 and 4 work, then 12 will also work. All right, so for number 11, I shouldn't have written that here. I should have put it off to the side, so I can't finish off my chart nicely, but this one's a little harder to explain. And I haven't written it down in a while, so let me make sure I word it as clearly as possible before I give it to you. So find the sum of every other digit then subtract the sum of the remaining digits if the difference is divisible by 11, then so is the original number. Okay, so let's take a look at the number 3157. So you're going to first find the sum of every other digit. So the 3 and the 5. So 3 plus 5 is 8. Then find the sum of the remaining digits. So 1 plus 7 is 8. And subtract those two amounts. 8 minus 8 is 0. And 0 is divisible by every number. Okay? So 0 divided by 11 is still 0. So if you end up with a 0, then therefore this is divisible by 11. Let me show you a 5-digit number. Okay, so take the sum of every other digit. So 1 plus 7 plus 5 is 13. And then the remaining digits are 5 plus 8, which is also 13. Subtract, and you get 0. More like 99% of the time, your difference is going to be equal to 0. Okay, there could be an occasion where your difference is equal to 11, or something it's it's equally seen there. So that's your trick for 11. So any questions there? All right, so you might have questions like this in your homework. Which of the following is true? So the first one, 8 divides into 48,324. 6 divides into 48,324. And 4 does not divide into 48,324.
So the 8, we do the 3 plus 2 plus 4.
No, the 8, you have to do long division into the last 3 digits. Okay, so for the 8, do long division into the last 3 digits. Okay, so 8 into 324. Well, 8 goes into 32 4 times. With a remainder of 0, bring down the 4. Does 8 go into 4? No, so we got to put a 0, which gives us a 0, and then we have a remainder of 4. So is this a true or false statement? False. Okay, so this one is not true. All right, how about 6? What do you have to do for 6? Okay, so you got to check to see if 2 works. Is it divisible by 2? Mm-hmm. Yep, because it's even. Is it divisible by 3? Okay, how do you know? Okay, add up all the digits. And what'd you get? 21. Okay, so check divisible by 3. And therefore, since these 2 work, then this is a true statement. All right, so what's the trick for 4? Last two digits. Okay, so does 4 go into 24? Yes, so is this true or false? False, because it said that it didn't divide into the number. That slash on there means that it doesn't divide, so therefore this is false because 4 does divide into that number. Now some other vocabulary that I just want you to review before I let you go that you guys probably already know, like a prime number. A prime number is a natural number greater than 1 that has only itself and 1 as factors. So the number 2 is prime because only 1 times 2 gives you 2. The number 7 is prime because only 1 times 7 gives you 7. The opposite of a prime number is a composite number. Maybe you're not as familiar with that word. A composite number is a natural number greater than 1 divisible by a number other than itself and 1. In other words, it's not prime, but it's bigger than 1. So the number 6 is a composite number because 1 times 6 equals 6, but it's also divisible by 2 and 3. And then every number has a prime factorization, expressing a composite number as a product of prime numbers. So this is the prime factorization of 42. So you don't need to write this down, but the fundamental theorem of arithmetic tells us that every composite number has a unique prime factorization. So the two numbers aren't going to have the same prime factorization. It's like a fingerprint of the number. Now, if you're asked to find the prime factorization of a number, some of you guys might like using tree factorization to do that. You've probably done this before. But if you take 42, think of any two numbers that multiply to give you 42. You might think of 6 times 7 first. And then 7's already prime, so we go to 6 and break that down, 3 and 2. And that's how we came up with our prime factorization. So if we find the prime factorization of 120 using tree factorization, when it ends in 0, I tend to think of 10. It doesn't matter what two numbers you start with. You could start with a whole different, group of numbers. But 12 times 10 equals 120. And then 12 is 3 times 4. And 4 is 2 times 2. And 10 is 2 times 5. Right, so you have 120. Our smallest number is a 2. We have 3 2's at the ends of the branches. Right, so 2 cubed, or 2 to the third, because there are 3 of them. Okay, times 3, there's only 1 3, and you're only looking at the ends of the branches when you're done there. And then times 5. It'll say something like use exponents to show repeated values, something like that. And also be very careful, don't type an X when you're showing multiplication.